Participants, please stay with us. We'll start our program shortly.
गुंजन
Participants, please wait. We will waiting. We are waiting for our speaker. So we'll start our program shortly. So please stay with us. So a very good afternoon to all the dignitaries and participants present over here. I welcome all of you to the third day of the 2 weeks workshop on innovation in technology leading to entrepreneurship organized by IIC, IQAC and Innovation Cell GKCM JIS Group in association with Wipro Private Limited. Today's first session is on the topic hybrid optimization approach for energy control in electric vehicle controller for regulation of three-phase induction motor. For this session, we have Honorable Speaker Dr. Pramod Kumar, Associate Professor, Department of Electronics and Information Engineering, Jiangxi University of Engineering, Jiangxi, China. So now may I request our Honorable Speaker, Dr. Pramod Kumar, sir, please start the session. So the session is over to you, sir. Hello, sir.
Yeah, hello. Good afternoon,
Yes,
everyone.
yes, sir. Very good afternoon, sir.
Let me share my screen. So, okay, good afternoon, all. So, this is the
Sir, we can't hear you, sir.
hello, good afternoon, all. So, the topic is the mathematical problems in engineering innovations. The content covers what has been introduced by the ma'am, and there is some additional aspect of mathematical modeling concerning the solar power generation and modeling of solar panels. So, okay, let's begin. So, to start, the outline of the talk is I will briefly go over the innovation, define what innovation is, and talk about some mathematical aspect of innovation, how we can derive or write mathematical formulation for innovation, different types of innovations, and covering briefly each of those, and then how it is connected to engineering innovation, and then spending some time on the manufacturing process, engineering materials, material properties, heat treatment, sheet metal forming processes, and some other processes in the manufacturing sector. Because when we say innovation, we are talking not only about the idea, we are talking about the implementation. And when the implementation comes into picture, that must be, translated into a business, and that business should be able to provide a output in terms of serving the customers and the people in real life. So that's why these different aspect of manufacturing process, materials, and their properties are important to understand how we can use those materials by understanding their behavior properties to probably So and then what is the mathematical aspect of the engineering, and how we can mathematically model different important processes when we try to establish a particular business or manufacturing of the product, because it is very important to understand in terms of mathematical aspect of it. Otherwise we will not be able to really implement in terms of translating that idea into a product and manufacturing it and finally serving the customers. And then I will discuss some the basic of mathematical modeling, and one of the important tool for mathematical modeling is MATLAB. So I'll spend some time on mathematical modeling, different types of modeling, what the principle is, and how it is connected to scientific method, and solving scientific problems concerning the engineering aspect of it. And then moving to my case study or the work which is concerning to the topic which was introduced. Hello. I hope everybody can see my slides.
Yes, sir. Yes, sir. Yes, sir.
Okay, good. And then covering the different aspect of this three-phase induction motor and its control, which we have recently published in one of the international journal. And then discussing another aspect of one of the mathematical modeling related to modeling of a solar power system using MATLAB. And then finally, I will conclude my talk. So to start with, so referring to something new or to change made to an existing product, idea, or field. So that's how we define innovation. So one might say that first telephone was an invention, but not an innovation. The first cellular telephone, either an invention or an innovation. The first smartphone is an innovation. So we can think innovation in that aspect. So innovation is not just given by new idea or method. The definition of and the meaning of innovation can be defined a process that involves multiple activities to uncover new ways to do things. So it has multiple activities. It should not be confused with the creation of new and defining new or act of making something, inventing, producing something. However, new innovation can be realized with creativity. So creativity is very important aspect of innovation. People need to think outside the box because we are not supposed to repeat what has been done already. So we should not reinvent the wheel. So presently we are positioned in a fast-paced environment where technology is advancing and globalization is increasing day by day. This means distances only get shorter and competition is increasing. Customer expectations are more demanding. Disruption in the economy is more likely to occur. Now, one must think why disruption in the economy is more likely to occur. This is a very important point to think on. And this is also very important to understand how we can keep ourselves up to date in the field of teaching innovation or starting new business, starting new products. So this is very, very key point. Disruption in the economy is more likely to happen. So for a business or an organization to realize competitive advantage, it should be able to adapt and innovate to the changing trends and new generations. So trends are changing, the interest of the people are changing. With generation, the thinking process, the interest, everything changes. We can imagine now, right now, I'm sitting in here in the Xinyu, Jiangxi, and the most of the people are sitting in India, maybe other part of the world. So we are able to communicate only because there is advancement in technology. And technology is able to connect us so we can communicate in a real time. So many things has changed so that even the communication, mode of communication, sharing the ideas, even the doing the business, everything has changed. So that is one of the aspect of this point, disruption in economy is likely to happen. So this means we always need to be very active in thinking about the new ways of doing things and be ready to change. So innovation apply for management and organization on all levels. So this is not only at the senior level, but at all levels and all sizes in operating all industries. So innovation create bigger opportunities and are very critical for survival, economic growth, and success of a company, and in this aspect of a country also. If the country want to prosper economically, serve its citizens well, so they have to innovate. So innovating helps developing original concepts and is a driver of optimizing operations. Companies that innovate are able to set the organization in a different paradigm in order to identify new opportunities. So this is very, very important. Identifying new opportunities and best method to solve current problems. So in India right now, if you think what new opportunities we can think of. So there is a lot of issues of garbage management, garbage disposal, waste electronic component disposal. So there are various scope where we can see there's a very strong need to handle those problems, and then how we can come up with ideas, maybe new processes, new the product which can help us to solve these problems. So in order to realize innovation, leaders should be open-minded and collaborative. So collaborative is very, very important in this case. We should be open-minded, we should be ready to collaborate, we should be ready to sit together, discuss with each other, coming up with ideas, listening to ideas, and how we can bring that idea into implementation. So that's why it is very, very important to listen to each and every idea and see how we can make that useful for our implementation of the idea, so that we can bring the real change in the society as a technical person. So feeling comfortable with uncertainty and manage changes are behavioral components of to innovate. So this is one of the things I think India need to do a lot of work in this. Feeling comfortable with uncertainty and manage changes. So this is very, very important, especially the people who are in the management. So that is very important thing to address. Innovative leaders are curious and are optimistic since they dare to take risk. So no one knows where innovation will bring the organization or individuals. So that is also another aspect of this. So leaders should be open-minded. They should be ready to accept new ideas, collaborate, and should be take uncertain steps. So on the other hand, everyone is an innovator because the innovative ability is in all of us. Since we were born, we innovate by learning, by doing. If you can observe a child, so child is curious all the time, and every time he is trying to learn, and sometime he is successful, sometime he might not be successful. So, but the problem in the today's time is pitfall is that the education system, the schools, even engineering colleges, they emphasize only on the setup way of education. Just do these things, learn these concepts, and be ready for the jobs. So that need to be a little bit changed. There should be more practical aspect in terms of how you can solve the real problems which are existing in the society, in the industry. So that should be more projects, real-time projects in terms of solving the real problems of society. That should be brought in the curriculum of even the management schools, even the engineering colleges. So that is one of the big things which is lacking right now in India. This has diminished our ability to innovate, while the ability to innovate is higher value. So we cannot think innovation if we are thinking only about our security of the job. So that very important point is here. So it is a higher value. So you have to think beyond your box. So which comes from free and out of the box thinking. So innovation and invention are not the same. So if we put mathematically in an equation, so we can say innovation is invention times commercialization. It is not plus, it is times. It's a product of two things, invention and commercialization. So this means if we do not have both, this means if we don't have invention or commercialization, then we can say we don't have innovation. So to have innovation, we need both invention as well as commercialization. So we need an idea, which is we are talking about invention, and how we can bring that idea into a product which can be commercialized to serve the society, serve the customer, to solve a real problem. So that's what innovation means. So we need both invention as well as commercialization. So it must serve the customer in the real world to generate value or solve some real problem which are existing. And idea might be easy. To come up with a new idea is quite easy, but on the other hand, commercialization is very, very difficult. A lot of different aspect is highly non-linear, highly dynamic, and we need to have the adaptive mindset to bring commercialization. And there are other aspects of commercialization also. There are market study, uh, bring the people who can invest in the idea, and then making the product ready and then launch on the real on the right time, and then solving the problem. So if you think in today's world, in technological world, Apple is the most innovative company in the present times. Now one must think why it is most innovative company. If we see the history of the Apple, if we see the first product when the Apple came into the market until now, they have been innovative all the time, and most of their products are very reliable. People, feel comfortable, and people feel really secure when they use Apple product. So the reason is that bring, they are able to adapt to the change which is happening in the even the new generation, new behavior of the uh, new generation, and then they are able to commercialize the idea what they have. So which create terrific value in the market, and that serve the customer as well as the investors. So innovation is a process of translating an idea into an original product or service which satisfy a specific customer needs. So there are few types of innovation that we can look at: disruptive innovation, breakthrough innovation, radical innovation, incremental innovation, and sustaining innovation. So what disruptive innovation is: creates new markets and new categories of the customers, utilizes old technology in new ways, harness the power of modern technology, create new business models. So one of the example is personal computers. So personal computer was an disruptive innovation. Then we have breakthrough innovation, which is out of the blue solution that creates a global paradigm shift, employs new technology. Customers don't realize they need it until they experience it firsthand. Forever changes life as we know it. So electricity was breakthrough innovation. Similarly, the wireless communication was a breakthrough innovation. Because of the wireless communication, every one of us is using a smartphone or wireless phone. Radical innovation is reshape an existing industry convention to create something, brings new benefits to the consumers, catalyst for creating new markets, meets the demands of the current generation. Digital photography is radical innovation. Now we have incremental innovation, which improves a product over time through small changes, add new features, tweak and improve overall design, driven by how consumers desire to use the product. So that we can correlate with the new generation. As the generation changes, their interest, their behavior, their way of working changes. For that, incremental innovation is also very important. So we can think a right example for this is a bicycle. There has been step-by-step improvement in the bicycle. Moreover, we can also take an example of a Apple iPhone. From the first iPhone to till now, you can see there is an incremental change in its features and its look also. So this is the example of incremental innovation. Now then we have sustaining innovation. Improvements made to an existing product by producing consumer needs, does not shift company's goal, expands company product line, giving the consumer more choices, keeps the business alive by retaining loyal customers. So iPhone development over time, this is sustaining, right? So any question up to this point? Anybody has any question or anything which is not clear? Hello? In case if anybody has any question, they can type in the chat box, or they can even raise their hands and then we can discuss. Okay. Innovation is critical success factor for any organization to survive and thrive. Continuously changes context of the company. It increases your value to customers. It also increases company growth by getting new customers, by getting existing customers to buy more often or buy more. By getting customers to pay more, it increases your competitive advantage. It also increases your attractiveness to collaborators. Innovation improves the strength of your company culture. Power of innovation is to create positive energy and motivation within the company. A combination of new idea, new technology, engineering, and its commercialization to serve customers in the real world to generate value. This we can correlate with the engineering innovation, since the topic of the talk is how the innovation is connected to engineering. So in terms of engineering, this must be applied to some engineering tech or some new technology which is related to different aspect of engineering, and that can be part of engineering innovation. Or we can put it in another words, like a process of translating an idea, engineering related idea, into an original product or service which satisfies a specific consumer need related to engineering aspect of the product. So now, going further, let's spend some time to briefly look at what engineering is. Most of the attendees must already be knowing because they are working in a similar field, but we will look briefly what engineering is. The application of science, the optimum conversion of the resources of nature to the uses of humankind. So, as per the definition given by Engineers Council for Professional Development in USA, the creative application of scientific principles to design or develop structures, machines, apparatus, or manufacturing processes or works utilizing them singly or in combination, or to construct or operate the same with full cognizance of their design, to forecast their behavior under specific operating conditions, all as respects an intended function, economics of operation, and safety to life and property. So this is the definition of engineering as per Engineers Council for Professional Development in USA. Why USA? Because that is the country which is leading from last almost a century in engineering innovation. Sometimes the term engineering can be loosely defined as a as per the definition by Great Britain as the manufacture or assembly of engines, machine tools, and machine parts. For that, we can also look back its root of the word. The root comes from the Latin ingeniare, which means to create, to engender, to produce, to cause, or to give. The early English verb engine means to contrive, which means planning, technique, and efforts. So you can think in examples of catapults, floating bridges, assault towers, and then later on, the counterpart of the military engineer was the civil engineer. And then onward, we can see the development of different field of engineering, civil engineering, mechanical engineering, electrical engineering, and then there are other electronics. These days, so many specialization has already come into picture. Now, these are some of the branches of engineering: mechanical, mechatronics, mining, chemical, electrical, software, and civil. So looking up to the mechatronics, so device, the control system, combining electrical engineering, mechanical engineering, and computer science and control. So this can be also related to IoT, even artificial intelligence. Okay, these are some of the schools in our university, where my previous university. So again, we can correlate this with the demand in the field. So there are different engineering branches, and accordingly we have different schools set up so that we can prepare the good engineer, which can be good innovator in the future, which can solve the real problem in the industry as well as the society. So now we'll spend some time on the manufacturing processes, and there are some other aspect of the engineering which is already being in the industry has been used. So manufacturing process, we can see the different manufacturing industry and there are different manufacturing processes. Here the 3 robots are assembling a automobile. Here we can see the gear, the different gears, and then of course when we see any mechanical parts, we have to think how it came into picture. I mean, how it is coming into the real in the present shape. Behind this, there have been design aspect of it, there have been material aspect of it, there have been complete manufacturing process aspect, testing, and then finally using in the field. So now this one is the making the manufacturing of the electronic chip. So these are the different manufacturing processes. I'll briefly go over these, and then we'll spend more time on the other aspect of the presentation. But if anybody has any question, they please raise your hand and then we can discuss that. Now moving on to engineering materials. So here you can see because of the different materials as their property, we are able to use them for different application. And when we say we are able to use them for different application, we must understand their property. And by understanding their property, we can see what is the best application, best usage of that particular material. Some of the property of the engineering materials are tensile, ultimate strength, ductility, the melting and boiling point, electrical and thermal conductivity of the material, toughness, and then of course when we say material, we have to see the periodic table which has been arranged in terms of their atomic number, atomic mass, and then their properties also. So by knowing the property of the material, we can see how we can use this particular material to maybe bring up new product in the market, which can serve a particular purpose. And we'll see in one of the example how why I'm discussing these and how it is related. So now we have here different products which are already in the market. Because when we say this, they are also, when these products came into the market, they were innovative products. They were really solving some problem. They were serving the customers. And of course, when we look at these, they are basis of these material, these different products is different material. And when we say different material, we have to look at their properties. So they had toy bricks, tap, toy car, spanner, medals, cup, can, saucepan, terylene t-shirt, nylon sleeping bag, tire, glass, magnesium wheel, coin. So now here is the picture of a typical bicycle. When we look at this bicycle, there are different parts of the bicycle are made of different products, different material. So here the brakes are aluminum, the spokes are steel, and suspension spring is tensile steel, and the quick release is made of cam aluminum, pedals are aluminum, chains are hardened steel, carbon steel, gears are brass bearings. So each and every part of the this bicycle is made of different materials. Now we can go back and look at it, why it is important to understand the properties of the material, because by knowing the property, by knowing the basic of different material, we can come with the idea how we can use this material depending on their property for particular application. And here this is the best example where we are combining different materials, putting them together, serving a very useful purpose. Here, when we say purpose, this is a bicycle which is helping us to commute. If you use bicycle more, of course, we are reducing the pollution. And the design of the bicycle has to be light in weight. It should be strength should be sufficient. When we say strength, each and every part of the bicycle is not required to have the same strength. That's why we are using different material at different part of the bicycle. So brakes are made of aluminum, not hardened carbon steel. So I guess I'm able to clear my point of discussing the material, their properties, because this is a really good when someone who came with this bicycle in the market as a business. So that time you can go back and see how it is important to bring these things together and coming up with the bicycle which has so much variability in terms of material and because it is serving the purpose of lightweight, it is serving the purpose of strength, at the same time maneuverability of the bicycle. So now, so these are some of the important physical property of material: density, melting point, specific heat, thermal conductivity, and electrical conductivity. Why it is important? Again, because by knowing the property, we have some idea, we want to implement the idea. When we are implementing the idea, we need the raw material. When you are using the raw material, we must be using different materials. We must know what their basic fundamental properties are, so that as an engineer, as a technical person, we can work out on the mathematical or the property aspect and see how we can use that. So again, there are some more properties like strength, elasticity, plasticity, ductility, malleability, toughness, heat transfer, and heat treatment. Now in heat treatment, there are different processes: nitriding, flame hardening. Now, once we have the material, we are not going to use the material in the same shape all the time. Depending on the requirement, we might need to change the shape of the material. For that, we have forming process. So we can form the material in a particular shape which is beneficial or useful for us. So here we can see different shape of the material depending on the application that we are using. So sheet metal forming process is important in that aspect. So, and there are different sheet metal forming processes. Now we also have roll forming process. Here see a big roller machine where we are forming a particular sheet in a particular shape, which can be used for various different purposes. We have spinning forming process, and these are the output of these different sheet metal forming process. Each of these item we can see in the screen has a different shape. Now, by looking at these shapes, you must think why they have different shapes. Of course, they are serving some different purpose in different particular, maybe some different machines or different product. So that's why all these different metal forming processes are important. Now then we have deep drawing process. Then we have stretch forming process, and then sheet hydro forming process. So we also have ironing forming process, and then incremental sheet forming process. Looking at these different sheet forming process, we can go back and look again on those shapes of different materials. Here in these two slides, we can see the different shapes. We are able to achieve these shapes by these different sheet metal forming processes. Now moving on further, we have rapid prototyping operations. So rapid prototyping is a class of technologies that can automatically construct physical models from computer-aided design data. It is widely used in automotive, aerospace, medical, and consumer products industries. So when the people first time came up with this idea and then invented this machine, this was in itself is a breakthrough, because this 3D printing these days is very, very useful in most of the universities, research focused university. They do have this rapid prototyping machine. When the graduate student or a research scholar is working on some particular project, and if they need to make some real item to use in their research work, so this is one of the very, very useful. And not only that, there are many industrial aspect also. Many things you can make using rapid prototyping machine these days. And even you can have a new business also. You can make even customized products, fast customized products. So these are some of the examples of different items and products which are made using rapid prototyping operations. So you can see different goggles, tables and chairs, material of different shapes. By looking at the shape, you can see this kind of shape is almost impossible to make by any other manufacturing process. So this kind of rapid prototyping machine is a real a big innovation in this field. Not only this, we can also make some mechanical parts which are really strong in strength. So here we can see the spanner, different gears. So these are really high stress application materials. So this rapid prototyping is not for soft products. So this can be also used for really hard, sustainable parts of the different products. So here is another example of rapid prototyping items. So this is the rapid prototyping machine, which is making a new product here. So how does it work? So in this machine, we have a laser, we have a scanner system, and then we have a two piston. One piston is fabrication piston, another is power delivery system. One piston is moving down, one is piston moving up. And then we have a roller which is delivering the powder for the item to be made. And then finally we are making this product here, cup, yellow color, and this is the cup that we are making. So that's how the rapid prototyping machine works. So here is one of the graduate student who is already designed a prototype, and then he's just checking is how she can use for her research project. Now, any question at this point? Anybody has any question or anything that we can discuss before I move on? Okay, if no question, then now since the topic of the talk is mathematical problems, engineering, innovation. So why mathematics for engineers? That's the first question we must ask. There are a few key reasons why mathematics is important for engineers. The laws of nature, Maxwell equations for electromagnetics, Kirchhoff's laws for circuit analysis, KCL and KVL are mathematical expressions. Mathematics is the language of physical science and engineering. Mathematics is more than a tool for solving problems. Mathematics can develop a logical thought process and intellectual maturity. It is critical that engineers learn to visualize abstract concepts. Engineer must know translating word problems into mathematical expressions. Numerical simulation on a digital computer is a powerful and effective tool that is being used by an increasing number of engineers these days. Going back, even this machine, when you are designing this product, when you are making this product, so of course there is a data in the system which has the all the 3D data of this particular item is available in the computer in terms of data, and that has to be translated in the real product. Of course, in this translation process, there are a lot of mathematical computation and calculation are involved. So that's why for any product development, mathematics is the backbone. Engineering as well as. Anybody has any questions?
Mathematics for engineering.
Okay, any question up to this point? Okay, moving on further. The key technical skill of an engineering mathematician is mathematical modeling. So problem solving of this kind is best learned by hands-on experience using case study applications spanning engineering, the life science, medicine, climate science, energy, data science, robotics, and more. Mathematical modeling is essential to tackle challenging open-minded problems and putting theory into practice. For this, I can give one example. I attended a summer school in Netherlands in January, February 2018. So that was a 1-week program where starting from Monday to Friday, in the first half of the Monday, everybody has to get together, and then there was a team formation. And once the team was formed, and there was a problem assignment. So the problem was assigned in the beginning of the Monday, in the first half of the day, and then each and every team started working on their project. And by the end of the day, by Thursday afternoon or evening or Friday morning, they must be ready with the output of the solution of the problem. Output means the solution of the real problem, because the people from the industry are coming, they are bringing their problems, and the university is organizing a summer school where the university is inviting researchers, graduate students from all over the world, and the different people from different countries, different disciplines, also different branch of engineering, they are working together to solve a real problem which exists in a particular company or in the industry in 1 week time. So these kind of programs are really, really important to broaden our understanding, how you really understand the problem first of all, and how you translate that problem to paper, and then once you translate the problem into paper, how you can bring the solution of the problem. And then once you have a solution on the paper, how you can bring that solution into the real product. So that's why, and basis of all this is mathematical modeling and calculation and computation. So engineering mathematics is the art of applying math to solve complex real world problems. For that, we need mathematical modeling. So combining mathematical theory, practical engineering, and scientific computing to address today's technological challenges. So now, we're talking about mathematical modeling. So what do we mean by model? So model is a miniature representation of something, a pattern of something to be made, an example for imitation or emulation, a description or analogy used to help visualize something. An example is an atom that cannot be directly observed. A system of postulates, data, and inferences presented as a mathematical description of an entity or state of affairs. So modeling is an activity, a cognitive activity in which we think about and make models to describe how devices, objects, systems of interest behave. Many ways to describe are using the words, drawing or sketches, physical models, computer programs, mathematical formulas. I can give you 2 examples. One physical model in our undergraduate, when I was a graduating student in Marine Engineering Research Institute in Kolkata in 2002, that time we made a 4-ram hydraulic steering gear. So that was a real physical system. So each and every part was, handmade using different lathe machines, shaper machines, different material that were available in the market. So our group of 4 or 5 students, we made that by a real physical model. So that was model of a 4-ram hydraulic steering gear. Hydraulic steering gear is used in any boat or ship to steer the ship. And then mathematical example of mathematical I can give back when I attended this summer school in Netherlands. That time we were working on the designing a test for testing the bearing. When you have a bearing of any, let's say any machine. So how do you test the bearing? Once the bearing is ready, how do you test that this bearing is going to last? How it is reliable? For that, we have to design a test. For that testing, we have to do some mathematical modeling and come up with some proof that this particular testing method is going to work for this particular product. So that was the example of mathematical aspect of this modeling. So we can have different ways to model the things. So modeling of devices and phenomena is essential to both engineers and scientists. Very practical reasons for doing mathematical modeling. And in addition, engineers, scientists, and mathematicians want to experience the sheer joy of formulating and solving mathematical problems. So that is very important. Interest and enjoying what you are doing. The passion for the particular thing must be there. So, okay, mathematical modeling and scientific method. So in the real world, we have some phenomena. So that phenomena we can observe by making observations. In the conceptual world, using words, using mathematical equations, and once you have to make good predictions. So that's what this way we can connect the real world and conceptual worlds by having this kind of roadmap, because when we are doing the mathematical modeling, of course, this has to be related to some physical phenomena or product, and we are using pen and paper and ideas and processes that we know, theoretical processes. So this is the way to this is the scientific method, how our conceptual model of the world are related to observations made within that real world. Now here is another example of where we can see the principles of mathematical modeling, a first order view of mathematical modeling, how the questions asked in a principled approach to building a model relate to the development of that model. So first we have object or system. We ask the question why, what are we looking for, find what do we want to know. Then we have a model or variables and parameters. Once you have these variables and parameter and model, so we have given what do we know about this thing. Assuming, if we are not knowing something, can we assume something? And how should we look at this model? And then once you have this something in hand, then you can see, can we use this for prediction? What will our model predict? And once you have some model prediction, then you can see, can we rely on this prediction? When we ask this question, can we rely? We have to test it. So test means verification. Verification must be used. Are the prediction good? Good means, are they realistic? Are they helping us maybe to improve our understanding, or maybe helping to further development of the process? And then if it is not good enough, then you go back to the model variables and parameter, maybe modify, tweak these variables and parameter, and then change the models unless until you test and verify the model, and then feel that this model is good enough so that we can bring this into practice. And then finally validate, accept predictions and use it for the application that you are using for. Then solving scientific and engineering problems. Scientific computing, computational science uses computational methods to solve science and engineering problems. The modeling of natural systems using numerical simulation is an important area of focus within scientific computing. These models are often computationally intensive and require high performance computing resources. So scientists and engineers often create models using applied mathematical methods, Fourier analysis, numerical linear algebra, solving ordinary differential and equation and partial differential equation. Models are often implemented using programming languages, and MATLAB is one of the most commonly used tools, which is a high-level language and interactive development environment with built-in functions for scientific computing. So here we can see some aspect of mathematical modeling with MATLAB. So we use math to describe our world. So mathematical modeling is the use of mathematical language to describe a system or process. Here we have input. So input, we have observation, we have some data, then we make mathematical model, and then we use that model to get some output. Here is another example of the same theoretical concept in terms of lift on aircraft wing. So when you are designing an aircraft wing, so how much that lift must be? So for that, we have mathematical model. Uses of mathematical modeling is forecast system behavior, optimize system behavior, design control system. Forecasting, optimizing, and designing. So these are the different uses of mathematical modeling. And we almost every day we use these in our day-to-day life these days. In the weather forecast, we are using mathematical modeling for forecasting the weather. The technical computing workflow, you have access to files, software, hardware, equations. Then you explore and create data, mathematical modeling, algorithm development, application development. And then finally, once you have the product in hand, then you share by reporting and documentation. Output for design and deployment using MATLAB, Excel.NET, C, C++, Java.dll or .exe. So this way we can bring the observation from the real world in terms of files of, and then bringing up with mathematical model and then testing it that this is going to help us, and then sharing that so that the output of the model can be used to bring real change in making a product which can be used in the real world. Now, there are three types of modeling. One is parametric modeling, one is black box modeling, and then first principle modeling. So parametric modeling uses a known model that maps the independent variables to the dependent variables. So we have two variables, independent and dependent, with a set of constants unknown. So that is parametric modeling. So this means we have parameter in this. Another one is black box modeling, which uses an automatically created model that learns to map the independent variables to the dependent variables. So it learns. So machine learning, you can say, is a black box kind of modeling, where we don't really know the exact relationship between two variables, but it learns by different algorithms. It tries to learn what is the best relationship between two variables. Then we have first principle modeling, uses a model derived directly from the laws of physics without making assumptions such as empirical or fitted parameters. For the parametric modeling, these are the we can use when a relationship between predictors and response is known. So we know the relationship here by like this model, mathematical equation is the relationship between predictor and response. Once we know this one, then we can use parametric modeling. On the other hand, one example of this is fuel economy analysis. So in this case, objective is to study the relationship between fuel economy, horsepower, and type of vehicle. Inputs, historical fuel economy data for cars manufactured between 2000 to 2012. And then you can use this approach of modeling and see in graphical form. And this is the equation which gives us the relationship. MP equal to B1 plus B2 over rated HP, rated horsepower. The another one is black box modeling, where we don't really directly know what is the relationship between the two variables, input and output, or dependent and independent, but we use black box modeling to come up with some relationship between the two. So neural network, support vector machine, Gaussian processes, decision tree, these are different model structure for black box modeling. First principle modeling, we use when the relationship between the predictors and response can be defined with analytical equations, build the model directly from first principles. Here you can see a pendulum. So we know the physical properties of this, and we know the kinetic, like how does the kinetic energy and potential energy are translated. So we know the behavior of the pendulum. When it is swing, what forces are acting on this, vertically downward forces, forces toward the center of this attachment of the. So by knowing the principles on which a particular object is working, we can write equation by first principle. So here we are using Lagrangian equation of motion, and then we can model this system. So for this, we can use symbolic solutions, DSolve, numerical integration, ODE 45, ODE 23S, constraint minimization. So these are the tools available in MATLAB that we can use to model a particular behavior of the object using first principle. So one demonstration for this is of crane motion. So this is the realistic example where you see in the port, when the ship comes near the port, then the crane has to be used to transfer the goods from place A to place B, from the shore to the ship. When the ship is there in the dock, so this is not very stationary object. Because of the sea currents, there is a lot of rolling and pitching is happening even when the ship is anchored. So this is a kind of challenging problem. So in this case, we have to model this behavior of the crane, behavior of the ship, how it is changing its position due to sea currents, and it is highly dynamic. It is highly dynamic, it is highly nonlinear system. So for that, this is really very realistic example. And if you see this plot, here you have different steps. First, the blue one is acceleration. Acceleration is increasing from 0 to a certain level, then it remains at that level, and then it decreases to 0. It remains 0 for some time, then it goes to negative, and then stay negative for some time, then it comes back to 0. So this means the crane has to lift the item here, then increase the speed, accelerating, maintaining that in the midway, and then decreasing to 0, and then due to inertia, it keep moving. We keep decreasing in negative to surpass the inertia, and then finally coming to zero. And this is highly dynamic, highly non-linear system. And you can imagine how our mathematical modeling is helping to solve this kind of realistic and very challenging problem. So in this case, of course, the control of the crane is very important, because we cannot control the position of the ship. Of course, the position of the item on the shore are fixed, but the control of the crane and swinging motion is very important. To make this control very realistic, very like optimal, we must model it accurately. So for that, you can see how useful tool this is. Modeling this kind of realistic system is very challenging problem. So now moving on to the one of the topic that was introduced by the introducer, like about one of the recent paper that we published. For in this, we are trying to come up with using some optimization technique to come up with the study some different control algorithms for a three-phase induction motor applied to electrical vehicle. So here is you can see the cross section of a electrical motor, three-phase induction motors. So the most important part here is the rotor and stator. So these are the most important part. Because of these two, it is functioning. The rest, all other parts are also important, but these are the very critical parts: stator and rotor. Excuse me. So the motor is used to convert electrical form of energy into mechanical form. According to the supply, motors are classified as AC motors or DC motors. Depending on the input supply, it is alternating or direct, we can classify the motor. The induction motor, especially three-phase induction motors, are widely used AC motors to produce mechanical power in industrial application. Almost 80% of the motor is a three-phase induction motor among all motors used in industries. Therefore, the induction motor is the most important motor among all other types of motor. The three-phase induction motor is a type of AC induction machine motor which operates on three-phase supply, as compared to single-phase induction motor where single-phase supply is needed to operate it. There are three-phase supply. There are three wires which is supplying three voltages, and each voltage is 120 out of phase to another one. The three-phase supply current produces an electromagnetic field in the stator winding, which leads to generate the torque in the rotor winding of three-phase induction motor having magnetic field. The relation between synchronous speed and number of poles is given by Ns is equal to 120 F over P, where F is frequency. It can be 50 or 60 hertz depending on which country you are working in. In US and UK, it is different. One country has 50 hertz, one country has 60 hertz. And P is the number of poles. And this number of poles must be even, because north and south pole cannot exist like in single. If there is north pole, there must be south pole. So this P must be even number. And Ns is synchronous speed. So if the number of poles are more, then speed will be less. And of course, the frequency will be fixed. Either it will be 50 hertz or 60 hertz. Now, AC induction motors offer, so some of the reasoning why we are using AC induction motor. It has really good characteristics in terms of robustness, reliability, ease of control. They are extensively used in various applications ranging from industrial motion control system to home appliances. Now we can go back and look into this example of the crane, gantry crane. Here also in the crane, what we have a motor in there. In the crane, we have a motor. When we are saying we are controlling the swinging of this crane, gantry crane, which is transferring the goods from port to from the shore to the ship, again we are controlling the speed of this motor. And you can see how critical, how challenging it is to control the speed, because the item we are delivering, one place is fixed, but the other place the ship is not fixed. The ship is always swinging, they're always rolling because of the current. If the weather is bad, of course the swinging, rolling and pitching will increase. And then when you are releasing this item from the crane to the ship, you might damage the item itself. You might damage the ship itself. If you are not accurate in lowering, you might drop this item in the sea only, or you might hurt the people working around that area. So you can see how critical, how challenging, how from the safety point of view, this is very, very challenging problem. And that gives us a motivation to and correlate how this control of AC induction motor is very important in various applications. So they are extensively used in various applications ranging from industrial motion control system to home appliances. In the home, we can think of washing machine. We can also think of the compressor, prime mover for your refrigerator, fans, and many more. However, the use of induction motors at its highest efficiency is a challenging task because of their complex mathematical model and non-linear characteristic during saturation. So it is not very easy to control because it has complex mathematical and it also has non-linear characteristics during saturation. These factors make the control of induction motor difficult and call for use of a high performance control algorithm such as vector control. So we need a high performance control algorithm for this kind of application. One of the method to control a three-phase induction motor is field-oriented control. In field, which is the control of torque and speed are directly based on electromagnetic state of the motor, similar to DC motor. Field-oriented control is the first technology to control the real motor control variable of torque and flux. So we are controlling the torque and flux, electromagnetic flux inside the winding of the motor. With decoupling between the stator current components and magnetizing flux and torque, the torque producing component of the stator flux can be controlled independently. By decoupling the two components, we can independently control the torque producing component of the stator flux. So that is field-oriented control. So decoupled control at low speed, the magnetization state of the motor can be maintained at the appropriate level and the torque can be controlled to regulate the speed. FOC has been solely developed for high performance motor application, which can operate smoothly over a wide range of speeds, can produce full torque at zero speed, and is capable of quick acceleration and deceleration. Now, this is very, very appropriate to go back and look at this application of gantry crane again. Because what we're talking here is exactly the same scenario. So you can see here there is sharp increase in the acceleration. And even in the velocity, when we see the speed, there is a dotted line, there is sharp increase in the speed up to a point. Then speed remains constant and there is sharp decrease in the speed. And then it becomes steady. So this is the scenario that's where we are talking about. Okay, any question, anybody? Looking at the block diagram of this field-oriented control, we have this permanent magnet synchronous machine over here, the circle, and then we are measuring some position using some sensors and some parameter of the working of this motor that we are using as an input for the reference. We have the reference also, the omega reference, and then real speed, and then torque. So velocity controller, current reference generator, and then we have ID ref, IQ ref, and control current controller. Then we have DQ and alpha beta, which is inverse spark transform. And then we have generator here, which is generating 6 components in terms of, because this is 3-phase motor. So for each, we are creating 2 components, and then we are basically, and here you have power supply, and then by this we are controlling this motor. Now in this there are 2 transforms, or one is called Park-Clark transform, when we are measuring this input supply to the motor, and then we have inner spark transform. We will see what it is mathematically as we proceed. So the working principle of field-oriented control. So I think some. The working principle of field-oriented control. The field-oriented control consists of controlling the stator currents represented by a vector. This control is based on projections that transform a three-phase time and speed-dependent system into a two-coordinate. So we are translating a three-phase system to a two-phase system, D and Q frame, time invariant system. So time invariant means it does not change with time. So these transformations and projections lead to a structure similar to that of a DC machines. An FOC, field-oriented control machines, need two constants as input references: the torque component aligned with the Q coordinate and the flux component aligned with D coordinate. So we have two coordinates, D and Q and D coordinate. The three-phase voltage, current, and fluxes of AC motors can be analyzed in terms of complex space vectors. If we take IA, IB, IC as instantaneous currents in the stator phases, then the stator current vector is defined as follows. IS is stator current, which is given by IA plus IB exponent J2 pi over 3. So this is a complex component. Then plus IC E J4 pi over 3. So this is a complex quantity. IS is a stator current vector, where ABC are the axis of three-phase system. Now, this current space vector represents the three-phase sinusoid system. It needs to be transformed into a two-time invariant coordinate system. This transformation can be divided into two steps. First is Clark transformation, where we are transforming ABC to alpha and beta, which gives output of two coordinate time variant system. First, we are getting time varying system. Then from alpha beta, we are translating to D and Q, which is called Park transformation, which gives us two coordinate which are time invariant. So now they are time invariant, so we can control this like a DC motor. So looking at the Clark transformation, so the three-phase quantities, either voltage or current, varying in time along the axis A, B, and C, can be mathematically transformed into two-phase voltages or currents, varying in time along the axis alpha and beta by the following transformation matrix. So this is the matrix that we are using to translate that to alpha and beta. And here is the graphical representation of the same. So here we have A, B, and C. Alpha is in alignment with A. Then we have IS alpha, IS beta, and IS is your final component. So IS alpha is IA, IS beta is IA over root 3 plus 2 IB over root 3. But these two phases, alpha and beta current, still depend upon time and speed. So Clark transformation gives us some, gives these two equation. They are still depending on time and speed. So for this region, we need Park transformation. For Park transformation, we have this equation IDQO 2 over 3 times this matrix, 3 by 3 matrix, where we have cosine theta, all different component of sine and cosine theta, where theta is the angle between rotating and fixed coordinate system. We can go back here. Here you can see the theta. In this, you can see the theta is the angle between this A axis and D. Okay, any question up to this point? So finally, what we have this ISQ and ISD in terms of IS alpha and IS beta, sine and cosine. And that's how it looks like graphically. Okay. Again, we can spend some time to look at the block diagram. So this is this machine that we want to control. We are measuring its parameter. We have some reference values, and then by the real value and reference value, we have these two values, and we have a controller, current controller in this case. Then we have this transforms in between, and then finally we are generating these 6 parameters, which are basically affecting the input to the machine. By changing the input values, different currents, we are changing the speed of the machine. We are controlling the machine. And we are also measuring what is going inside the machine. By this IA, IB, IC, here we have Park and Clark transformation. And then we have output is ID and IQ. And then again, we are using this to protection and auxiliary function also, because there must be some protection of the machine in terms of some trip. If something goes wrong, then there should be some safety features also. Emergency stop or some trips if there is excess of some of the important parameter, current or voltage, as a safeguard to the machine. So that's how it looks like. So why we are using this? Because it is helping us to give some very important advantages. Improved torque response, torque control at low frequencies and low speed, dynamic speed accuracy, reduction in size of the motor, cost and power consumption. So the reduction in size of the motor, cost has been saved, and power consumption has been reduced. Short-term overload capability. So these are the benefits that we are getting from this control method. There is another method that we study, which is direct torque control. Direct torque control for induction machine was proposed in middle of 1980 by Takahashi and Dippenbrock. DT is less sensitive to parametric variation of the machine, and its control algorithm is simple because of the absence of pulse width modulation of current controller and Park transformation. DTC control ensures high efficiency operation and provides accurate and fast torque dynamics. A simple structure of DTC control you can see here. We'll see the enlarged view of this in coming slides. Here you can see the enlarged view. A simple structure of the DTC. So here what we have again, this is the machine that we want to control. We are measuring current, IA, IB, IC, current calculation. And then we also have voltage calculation. These 1, 2, 3, 4 parameters. And here also we have transformation because 3 to 2 here. And then electromagnetic torque and stator flux estimators, psi, S alpha, psi, S beta, sector detection, and then here T, EM, estimated torque and reference torque, the flux, reference flux and estimated flux. And then finally we are able to change, make this switching table, and then finally 3 parameter here, which is going inside voltage source inverter. And then we are able to control the speed of this motor using direct torque control. So this is second method. So the electromagnetic torque is controlled using a 3-level hysteresis comparator, while the stator flux is controlled using a 2-level hysteresis comparator. The outputs of these comparators as well as the flux vector information are used to determine the switching table. So we are using the output of these comparator as well as the flux vector information to make this switching table. We'll see what it is. Now, for this, we are using DTC, direct torque control, and fuzzy control. So for this, we have reference speed and measured speed. So here is the fuzzy logic control. Here is the flux, reference flux and the measured flux, reference torque and measured torque, and this is the theta, estimated speed. And these goes inside this fuzzy algorithm switching table by fuzzy logic controller. And then finally we have these 3, SA, SP, SC, and then we are controlling this induction motor. So how does this fuzzy work? So we have input parameters, and then change in flux, change in torque and theta. We have fuzzification, some rules, and then after the rules we get some output that we send to decision making, and we make the decision in terms of changing some parameter which goes inside the machine by SA, SB, by changing SA, SB, SC, and we are changing this by controlling the speed of the induction machine in this case. Now, these two methods we studied, and to implement this control, we have to apply some optimization technique also. For that, I'll briefly talk about what optimization is. So optimization is choosing input that will result in the best possible output. So here you can see the 2 plots. Here in the lower plot, you have A and B point. These 2 points, we have maximum value. On the other hand, in the topmost right plot, you have multiple change in sign, sign of the curve. There is multiple change in sign. When I say change in sign, I'm talking about the increasing and decreasing. So there are, of course, there is one global maximum, but there are multiple local maximum and minimum in this case. So how does optimization help? Making things best they can be. Most effective allocation of effective resources. Producing a design with best characteristics. Choosing a control variable that will cause the system to behave as desired. So in this case, the last one, choosing a control variable that will cause the system to behave as desired. So this is the application that is we are using for this optimization. Okay, continuing. Now there are different optimization techniques. So one is heuristic approach, another is meta heuristic approach. In these two, in the meta heuristic approach, we have swarm based algorithm, trajectory based algorithm, evolutionary algorithm. And then in swarm based, the swarm based algorithm, we have artificial bee, cuckoo search, firefly algorithm, and particle swarm. We are using particle swarm. So they're different in each category. There are different algorithms for optimization. So we can study each of those. But in our case, we are looking at particle swarm. So this chart of the algorithm that we use using fuzzy techniques. If I explain this flow chart, we start with at one point, we measure ISK and TSK, current and torque. We initialize a index I, which is 0. Then we have flux, psi SK, and TEMK estimation. And then once you update these estimation by predicting the next value, K plus 1, then you have a cost function calculation, which is basically the real optimization is happening here. And then you update your index. And when you reach a certain index, if it is true, matching to certain index, starting from 0 to the total 8 step in this case. And then if it is not true, then you go back, repeat. If it is true, you see minimum F is out of these, you choose what is minimum. And then voltage vector selection. And then finally, you have this control parameter you can use to control your machine. So this is the algorithm. The execution of the prediction algorithm can be performed in 3 steps. The estimation of the known measurable variables, the prediction of the future behavior of the system, the optimization of the control outputs according to a cost function already defined before. So this cost function is already defined before. So here we are using optimization. Optimization of the control output according to a cost function already defined before. These steps are repeated at each sampling time step, taking into account the new measurements. Closed loop control is obtained by feedback from measurements used to predict and decide on measures taken to reduce the value of the cost function. Right? In this case, we are minimizing. So we are reducing the value of the cost function. And there is a feedback. Now, any question? How much time I have? Hello? Can anybody tell me how much time I have? Okay, I think I still have time. So let's continue. Okay, so let's continue. So now I have another example of the system. This was one of the examples that I discussed. So this is our recent paper where we are designing the control by studying different control techniques and optimization for 3-phase induction machine. And then I showed how it is applied to industrial operation and control and how it can help a business. It's a very realistic problem, and how it can help a particular business, because we are talking about mathematical method for engineering innovation. Here the innovation can be control of a particular machine. And how does this control help us? Of course, it will help us to save time. It will help us to be more safer operation. It can help us to minimize any accident and many more benefits we can get from this. Of course, it can help us to save the power. So that's how it can help us, our business or innovation in particular engineering operation or manufacturing operation, a particular operation, or maybe loading and discharging of the cargo. So that's how we can correlate with the topic that we are discussing right now. Now, another problem I want to discuss briefly is theoretical model of solar system using MATLAB. Okay, we already talked about MATLAB. MATLAB we can use for data analysis, simulation, algorithm development. So what is the basis of MATLAB and how it looks like work with MATLAB? So we are not going to that, but yeah, this can be used. Now this topic is related to the solar system. So solar system, this is related to solar system at the headquarters of the MATLAB, which is in Natick, Massachusetts, USA. So there is a theoretical model of the solar system that says what the energy production should be on a particular day. Again, this is a very applied problem. Now, here we have a mathematical equation of sine alpha, which is given by sine delta sine psi plus cos delta cos psi cos 15 LST minus 12. I'll explain what these terms are. But here in the plot, you can see on the y-axis you have production in kilowatt, and on the x-axis you have time of the day. So during the time of the day, you can see from around 6 o'clock or 6:30 in the morning to around 7 or 7:30 in the evening, we can see there is some production of the solar power using these solar panels, which are on a headquarter of MATLAB in Massachusetts, USA. So here you have two curves. One is from the measured data, one is theoretical maximum. So this theoretical maximum we are getting from this mathematical equation, and measured value we are getting directly from the measurement that we are making to the in the system by sensors. So let us see implementation of the theoretical model of the solar system as compared to the actual data collected. First, we need latitude and solar declination. So for the latitude are these circles which are parallel to the equator. So we need to know the exact physical geographical location of that particular place, in this case Massachusetts, USA, because we need to calculate the orientation of the sun, and then by knowing the orientation of the sun, how much intensity we can get from the sun, and then we can calculate this theoretical production. So for this, we have example of June 21st, the longest day of the year, that will give us the maximum amount of production of the solar, because during this longest day, as well as this longest days mean we have sun from maximum time, from morning maybe around 6:30 to almost 7:30 in the evening. So we are making this calculation of latitude and declination, and then we are getting this parameter in terms of radians. And then once you have latitude and declination, because we need these two parameters inside this equation to calculate this sine alpha, because this we are going to use to calculate the solar production on a given day. So this psi and delta. So we have these two parameters, latitude and declination. And then we have a time vector. This time vector we are converting into LST. LST stands for local solar time, because there are different time zones in USA. So for local time zones, about that Natick, Massachusetts, USA. So LST is that. From the time vector, we are generating a LST vector. So we have three parameters now: LST vectors, latitude, and declination. Going back, what declination is? Declination is this delta. Delta is solar declination, and latitude is this psi. and LST. LST is coming from time vector. Right? Anybody has any question? So this is your delta. Right? So now we got our LST vector to, we also got latitude and declination. And once you have these three, we can calculate sun angle. Sun angle is given by the same equation that we have seen before. Sine declination times sine latitude plus cosine declination times cosine latitude times cosine d 15 times LST minus 12. Now here you can see different orientation of the sun from the beginning of the day, where you have 0 angle. So sine this alpha is 0, going to maximum in the noon time, where sine alpha is 1. So 0 to,
Excuse me, sir.
yes.
Sir, actually, we are running out of time, sir. So please.
How much time I have? Shall I
So
conclude
actually,
now?
sir, the session is up to 2:30. So you can take 5 minutes.
Okay. Let me quickly go to the results.
Yes, sir.
So this is the
Thank you, sir.
equation we are using to calculate the incident. 1.4883 times 0.7 sine alpha raised to minus 0.678. So this alpha we are calculating to the using those that equation. In the equation we are using latitude and LST and declination. So once we have this S incident, we can calculate the production, theoretical production, by multiplying 270 times S inclination and sun angle. So this will give us theoretical production in a given day. Now let me show you the result now. Here you have these are the data that has been collected. So for 21st June and 26th June, you can see these two. 21st June is a little bit noisy data, but 26th June is very clean and clear data. Now here you can make the comparison between 21st on the right and 26th on the middle. So 26 is very clean data. So 26th we can use to calculate the theoretical production of the solar system at the headquarters of MATLAB in Massachusetts, USA. So yeah, let's say this is 270 kilowatt, but the inverter also has a limitation, so which can only allow it to pass 270. So again, that you have to make an adjustment of in the inverter by implementing some control strategy, and then finally you can use this to power your home. Maybe you can charge your battery of the electric vehicles. You can supply street lights in the home appliances, and many more application use of this power generation by solar panel. Now, once you have these theoretical models, you have scripts, you can translate, save those, and transfer to your colleagues and collaborators, and then use as you require. So this concludes my talk. So what I have discussed: innovation, engineering innovation, different material processes, mathematics, background of engineering, and how we can use mathematical modeling and scientific method, the principle of modeling, solving real world problems, and then 2 examples of 3-phase induction motor control and solar power generation. And in this we use fuzzy logic as well as optimization. And then the MATLAB is the tool that is helping us for the computation. And this concludes my talk. If anybody has any question, I'll be welcoming them, and I'll appreciate the efforts of WeGrow, Professor Ramesh Panda, and my school over here in Jiangxi. So, and thank you very much, and thank you for your attention, and thank you for your patience.
Thank you, sir, for your wonderful and informative talk. And now, on the behalf of Greater Kolkata College of Engineering and Management, we felicitating you, sir, with a digital memento as a token of honor. So please accept it, sir.
Thank you. Thank you.
This is for you, sir. Thank you, sir.
Thank you very much. Thank you very much.
Thank you, sir. So now we are moving forward for the second session on the topic Metaverse, a game-changing innovation for entrepreneurs. For this session, we have honorable speaker, Mr. Atif Priya, Director, Planning and Development, Advisor to Vice Chancellor, President Institutions Innovation Council, Senior Faculty for Implementation of NISP and ARIA, Nodal Officer at City University, Deputy Director, Entrepreneurship Development Cell, Head Seer City University, Ludhiana, Mr. Atipriya, Director, Planning and Development Advisor to the Vice Chancellor, President Institutions, and he is the head of LinkedIn Local Ludhiana, Director, Education for International Human Rights Organization, and having progressive experience in managing and leading various aspects of management spanning across high-paced business domains, Mr. Atipriya has excelled in establishing innovative and competitive initiatives, institutionalizing a strong performance-driven culture at the companies where he has worked. He is a PhD scholar, MBA IB, MCOM IB, PGD IPR, PGD IBO, ATC, and he is a certified CSR professional. So now I would like to welcome you, sir, at this session. So the next session is over to you, sir. Hello. Hello, sir. Hello, sir. Am I audible? Mr. Atipriya, sir?
Yes, ma'am. Yes, ma'am, you are audible.
Yeah. So, sir, please start the session. The session is over to you, sir.
Hello.
Yes, sir. Yes, sir.
Just give me a second. Actually, um, I'm joining from my laptop, but that Zoom is not working properly.
Okay, sir. Okay, sir.
Hello. I can share my screen now.
Yes, sir. Yes, it is
Right.
audible.
Thank you so much, first of all, for inviting me for this keynote session on metaverse, and thank you so much for the lovely introduction. I would be extremely sorry because I won't be able to turn on my video since I'm sitting in a government office, and means the protocols are here that we cannot turn on the video right now. So extremely sorry for that. And coming to the topic, metaverse, it's the buzz of the town these days, and means after Mark Zuckerberg changed his company's name to Meta, and it's the most keen, means sought after in Google keyword of the last 2 months. I hope my screen is visible to everyone.
Yes.
All right. So moving forward to it, so the topic is metaverse, like how metaverse is going to be a game-changing innovation for the entrepreneurs. Now, means metaverse may have started with the gaming industry, and but means this innovation it will spread, and it will be a game changer for many others. So, but before means we actually begin with it, let me give you a glimpse of the metaverse through Mark Zuckerberg's own video.
Imagine you put on your glasses or headset and you're instantly in your home space. It has parts of your physical home recreated virtually. It has things that are only possible virtually. And it has an incredibly inspiring view of whatever you find most beautiful.
Hey, are you coming?
Yeah, just gotta find something to wear. All right, perfect. Hey, Mark. Hey, what's going on?
Hi. What's up, Mark?
Whoa, we're floating in space. Who made this place? That's awesome.
Right? It's from a crater I met in LA.
This place is amazing. Ross, is that you? Of course it's me. You know I had to be the robot man. I thought I was supposed to be the robot. I knew you of nothing. Should we deal you in?
Sorry, I'm running late, but you've got to see what we're checking out. There's an artist going around Soho hiding AR pieces for people to find.
3D street art. That's cool.
Or something, I'll look at it. Hold on, I'll tip the artist and they'll extend it.
Wow. You guys like it here? I have another that you're gonna love. Check out this forest room. Oh, let's see it. Before you finish that fly, that's new. This is wild. Hey, one sec, pause. It's Priscilla.
Hey, you have to see this. Beast is going crazy.
Oh, I love that guy. Got to show that to the kids. He wants to send that to my dad.
I'll message him.
All right, see you at home. This place is great, Boz, but there's something I got to get back to. All right, so that's a glimpse of a few ways that we're going to be able to get together and socialize in the metaverse.
So, that was just a glimpse, like how metaverse is going to change the internet in the coming future. But, means recently much has been said about the metaverse, including the implications of Facebook, means renaming itself from Meta platforms. And, means some went as far as saying that metaverse will be the next internet. But what exactly is metaverse? And, means how it will be a potential game-changing innovation for businesses. Now, to understand this, means let's understand first the origin of metaverse. So the word metaverse, it was coined by Neil Stephenson in his 1992 science fiction novel Snow Crash. And means in that it referred to a 3D virtual reality world that evolved from the internet. And in his book, he mentioned a story where human beings in a crumbling society would escape to this realistic digital world, taking on the form of avatars to interact with one another, as well as with many software agents. You must have seen, I don't know, means some of you might have seen the movie or not, but there was a movie, Ready Player One, which showed that same scenario also. So, means currently in our real world also, means after this COVID-19 pandemic, an alternate world has appeared where people could, means escape to, and it's more attractive than ever. So metaverse, it will affect not only the businesses, means be the small, medium or big, but also, means potentially everyone it's going to affect. Surprisingly, only Facebook's now Meta is not alone who's pouring millions of dollars into building this digital world. In December 2021, New York's Republic Realm, they invested a record-breaking $4.3 million for metaverse real estate via, means the Sandbox. I'll show you what Sandbox is. And, means just a month before this record, Canada's tokens.com, they spent $2.4 million for digital land on Decentraland, which is another metaverse platform. Means now let's see like what exactly, means Sandbox is all about.
The Sandbox is a gaming virtual world built on the Ethereum blockchain where players can build, own, and monetize their gaming experiences using non-fungible tokens, NFTs, utility token, SAND. The Sandbox platform currently includes Box Edit, Marketplace, and Game Maker. Let's see what each of them does. They can become a non-fungible token, NFT, and sell it on the marketplace. Assets are made intuitively using voxels, the equivalent of 3D pixels. You can build all sorts of assets that can be also animated with templates. The Sandbox's decentralized marketplace enables the trading of in-game assets created on NFT Maker. Now, millions of players can enjoy creating, exchanging, and selling game assets published on the Ethereum blockchain to prove ownership and full monetization. Finally, the Sandbox's game maker allows players to build 3D games and with no coding knowledge required.
So you see, means the NFTs, they are now going to rule the market. Now, means some of the critics, they argue that these digital VR real estate and products, they're not real. however, na, the same could be said for money also, be it in the form of paper, plastic, or bits and bytes. And means money issued by central banks or decentralized cryptos, means they are not real in that sense, that their value depends heavily on commonly agreed and accepted ideas, trust, and human imagination. Now, let's take the example of chimpanzees over here. Chimpanzees trade among themselves, such as trading bananas for mangoes. But however, if a human being were to trade US dollars for bananas with a chimpanzee, it's unlikely to accept dollars, right? But however, the same person could easily trade the same money for bananas in a supermarket. So, as far as chimpanzees and the natural world are concerned, the money people use daily are not real in nature. So, but nonetheless, those that could move daily, the detractors could see how metaverse is a real innovation that will potentially change not just how the gear in many businesses, means, but how people will actually live, work, and play in future. Now, the current global pandemic, it has already changed how people communicate, work. But imagine with metaverse, you could go to the office in your VR avatar, means wandering an amazing architecture with daily changing decor, and the next moment you're brainstorming with your team for a marketing campaign while being in a creativity stimulating environment. Means and in just another moment you could just easily travel to some other world. So means these are just few of the glimpses. The center GIF which shows you, that's the metaverse which was introduced by Microsoft recently in their team feature, which enables you to interact with the team participant in your own individual avatar. So means every company is now in a rush to pool themselves into the metaverse. Now, metaverse, it gives a real 3D immersive experience of not only human interactions, but also of the products and services. Now, in metaverse, means that there is a possibility of demonstrating products. Like in the left hand side, you might be seeing that's the first H&M um, means showroom which has been opened in the metaverse by the H&M company. So means there's a possibility of how apparels would fit you and how you will look into them. You can do all that virtually, and means the possibilities are endless over there. So there will be opportunities for the businesses to set up the kiosks in means malls, transport hubs, and other high traffic spaces that provide high accuracy professional 3D scans. With such an avatar, means you get an exact fit for you. And means in any global pandemic or in any one, means I'll show you like how metaverse is changing the real estate
The
market.
latest big real estate market isn't on sea coastlines or in major cities. It's in the metaverse, where a growing number of investment firms are spending billions to acquire digital property. Owning land now in the metaverse is a little bit like buying land in New York 250 years ago. Metaverse real estate isn't all that different from property in the real world. It just exists digitally through the city, where users can simulate real life pursuits like shopping, playing games, or attending virtual concerts. There are houses that you can walk into, there are shops that you can go into and buy things. And this real estate in the metaverse is increasingly for sale. The idea behind investing in digital land is that once you own it, you can make money by developing virtual property and leasing it out.
We bought it because we want to do something very big there. We want to do something that's immersive and exciting, and in order to do that, you have to have lots and lots of space.
Of course, digital real estate is still considered a very risky investment. So what exactly led to this virtual land boom? And what factors make it so valuable? Right now, the metaverse is an evolving space that comprises multiple digital users can interact with. Many of these digital spaces appear cartoon-like, while others feel like virtual recreations of the real world. Andrew Kegel is the CEO and co-founder of Tokens.com, an investment firm specializing in cryptocurrency and metaverse real estate acquisitions. The land of metaverse looks a little bit like a movie word. That you have these parcels of land, you want to try to acquire as many parcels of land as you can afford. There are only a few platforms where investors can buy and sell real estate, each with their own unique cryptocurrencies. Each platform has a limited number of partners.
So you can imagine like what an immersive 3D experience you can do for your property viewing and inspection. Means thus the industry as well as many others will also be challenged by capital and human talent. Now, means as far as real estate is concerned, now when it comes to the retailing, now e-commerce will be transformed globally. Let me show you like how Walmart is doing. Now, if you see over here, this is the virtual reality platform, a metaverse platform, which Walmart has recently developed. You just need to present it and you'll get the virtual shopping experience.
Howdy. Thanks for visiting Walmart. I will be your shopping assistant module today, but you can call me Sam for short. Okay, let's get started. I have your shopping list loaded up and I'm tracking your oil change so I can let you know as soon as it's done. You see the tomato sauce on your left? Go ahead and grab that and then place it in your cart. Great. Looks like you need a good wine pairing. Take a look to your right. Your age has already been pre-verified through your profile, so no need to wait for an ID check. Just place the item in your cart whenever you're ready.
So you see like how Walmart is also going to, means enter into this e-commerce market of the metaverse. So, virtual malls, shops and shoppings, they may not be so much means trying about the virtual sessions, but in the real world, means selling and buy of virtual products with real world currencies are existing right now. So, means metaverse is well on its way to becoming an integral part of e-commerce, and means through a series of several technological and innovations all operating seamlessly together, the metaverse can now allow brands to provide consumers with an unparalleled online shopping experience. Now, technologies such as NFTs, augmented and virtual reality, they are providing unique opportunities for your brand to reach new customers in new ways. And companies, they're rushing to roll out metaverse platforms. Means like Meta's transport users to entirely new worlds, but they also include augmented reality experiences like Pokemon Go. It was a very popular game, which means made these kids addicted with the augmented Pokemons, which you can capture by throwing the Pokeballs. So means even the Microsoft, they have also recently means announced their own foray into the metaverse, teasing a new Teams product, which I recently mentioned. So, but means despite big all the tech's best efforts, it's the smaller players who will have a huge role to play within the metaverse. And this is because the metaverse will be a difficult to wall off, thanks to the large part of blockchain included in it. Now, blockchain, it will allow the metaverse participants to build and use decentralized technologies rather than rely on big tech players alone. But this will mean that there will be ample opportunities for the startups, and means they will be now forced to use their creativity in this wild new digital world. Now, if you believe the experts, means they believe that metaverse will signify the next step in our digital evolution. Means bringing new risks and opportunities along the new software and hardware. But means it will be the experience instead of the technology, which will play a huge role. Means metaverse is all about like how you experience the things, how you experience the virtual reality platform, whether it's going to be a boon for you, whether it's going to be a curse for you. So it means it's all the experience instead of the technology, which is going to play a huge role. Now, means, and based out of these experiences only, the startups and the entrepreneurs, they are going to build the business models around it. But they say that doing business in a metaverse, it won't be simple. So there will come a question, and there is a question which is rising, which is a topic of great debate also, that how to regulate it, how to regulate the metaverse, because so much data would be consumed by these companies, and means as per the experts, the 4G technology will not be able to adapt this metaverse. To experience it, you would be requiring new and improved products. You would be requiring the 5G technology, the high-speed data transmissions. So means there obviously comes that how to regulate all these things. Now, regulation, they will also play a role in the development of the metaverse. Because, right now also, if you'll see that many of the web startups, they're still flying under the regulatory radar. The ministry, they are not clearing it until and unless they provide that, okay, means the data which they are collecting, they are not going to, means breach the privacy of the people. You might have seen many cases and lawsuits filed against the Facebooks and Instagram. But, means still, there are many startups, and there are many eagle eye authorities who are regulating the work of these tech companies. So, and because of these regulations, and because of means this uh, an open ocean of creativity for the entrepreneurs, there comes a list of hacks, there comes a list of scams. And means simple, so sometimes a small simple error can also bring down the whole bunch of data. So now questions of how to prevent fraud, eliminate the copyright infringement, and means guarantee the integrity of digital environments, they are yet to be answered in detail. And means there are many debates, and they will continue to be, like how to make metaverse a safe place that accounts for the human rights that have been means developed and enforced to varying extents. So given that all these issues that exist in the real world today, it only emphasizes their complexity and the trade-offs required to resolve them. But like I said earlier, that doing business in the metaverse won't be simple. But then again, doing business in real life is also not. So always, I mean, the young entrepreneurs, they need to develop their innovation skills now. They need to rely heavily on the technology in order to survive in the cutthroat competition. Because right now, just after the announcement, although the NFTs were in the market for quite a long time, but just after the announcements of Meta and of Microsoft and of tokens.com, the value of NFTs, they have shoot up like anything. They have skyrocketed. And there's a huge potential for business to thrive in this. All the investors, they can invest in the NFTs, and then they can reap maximum benefits within a couple of years. So metaverse may have started with the gaming industries, but game changed it, and this innovation will spread, and it will be a game changer for many things. So as means Mark Zuckerberg has put it, that in 5 to 10 years, metaverse will be a mainstream, and it's going to means revolutionize the web 3.0 into web 4.0, which they are now popularly coining it the term. So that's all from my side. It's a short session. So if in case, like, if you have any questions, and if you want to discuss something, I'm free to handle this. Thank you so much.
Thank you, sir. Thank you so much. So participants, if you have any questions, you may ask now.
Okay, so I have a question, that what are the applications of metaverse? Meta, the Facebook itself, it's one of the application of metaverse. If you have heard about the Sony PlayStation VR, there are many games, there are plenty of games like which are the apps of metaverse. Then there is one application with the named Horizon. That's also that's an application which gives you a real immersive experience of the metaverse. Then there are some live streams also, which gives you a experience of metaverse. Like in India also, recently there was an announcement where the first virtual marriage was held. The bride and groom, they got married virtually in the metaverse itself. And recently, even Justin Bieber performed in a concert with the help of metaverse. So, and like I mentioned, then there are like safe sandboxes there, then decentralized is there. So there are plenty of applications which are coming up.
Thank you, sir.
Thank you so much, ma'am.
So, thank you, sir, for your wonderful speech. And obviously, the session was very interesting and informative one. So, now we are at the end of the session. So, sir, we have a digital memento for you on behalf of GKCEM. So, please. Yes, sir. This is for you, sir.
Thank you so much. Thank you so much for this. Thank you so much.
Thank you, sir. So we are at the end of the session. So we will see tomorrow. So good day for all of you. Thank you. And please everyone fill up the feedback form.